The Linux kernel. In this nugget and the next nugget, we're going to discuss the Linux kernel. We'll learn how to upgrade the kernel to the newest version so that we're up to date with all the latest security fixes. In this nugget, we'll perform the simplest kind of upgrade to the kernel. We'll use an RPM file. I'll run through it first on the whiteboard, and then we'll move out to the Linux screen and walk through the steps firsthand, one by one. Put on your thinking caps and let's get to work. Alright, well, let's start with some general discussion of the Linux kernel. Now, the first thing I want to talk about is the idea of a monolithic versus a modular kernel. A monolithic kernel has everything inside of it. When you boot up the system and the kernel loads into memory, the kernel has all of the functionality that it's going to need loaded inside of it, resident in memory. A modular kernel, on the other hand, will only have the most essential elements of the kernel loaded into memory when the system boots up. And then when the kernel needs some extra functionality, like a device driver for your printer or something like that, then a module for that element will be loaded into memory so the kernel can carry out that task. Now, a modular kernel, the stuff that's in memory is smaller usually at any one time for a modular kernel, unless like every single module is loaded into memory at once. Then it'll be the same size as the monolithic kernel. But most of the time, the modular kernel is going to be smaller, it's going to be more streamlined and more efficient, and only the stuff is in memory that is needed in memory at any one given time. Okay, so that's why we like modular kernels, because they're faster, they're smaller, they're eating up less resources. Now, the negative side of a modular kernel is that if the kernel needs to do something like, satisfy some print request, then it's got to load that module into memory before it can satisfy the print request. And there is a little bit of overhead in loading that module into memory to do that. But the negative side there is far outweighed by the fact that most of the time you've got a smaller, more streamlined kernel in memory. Alright, so then there's the idea of an initial RAM disk. A RAM disk is just what it sounds like. It's a disk image in memory. Okay, and the reason that we have initial RAM disks on my system, I need one because I've got a SCSI disk as the only disk in my system. Well, the SCSI drivers are not part of the base kernel. Okay, so I can't boot off of my hard disk initially when I boot up my system. I've got to boot off this initial little RAM disk that then contains the SCSI driver, and then it can load that in, and then the kernel can boot off my actual SCSI disk. Okay, so that's the purpose of an initial RAM disk, is to satisfy, in my case, that SCSI driver that's not present in the base kernel. It loads that in, and then I can boot off my SCSI disk. I can boot that full version of Linux. Now, there's a couple options for updating a kernel. One option that we're going to cover in this nugget is installing the new kernel from an RPM file. And not just an RPM file, but like a binary RPM file specific to our architecture. Just like we did when we talked about RPMs before, we had choices for RPMs for various architectures, and we're going to choose the kernel RPM that fits our architecture. The other option for updating a kernel is to customize, configure, install, compile, and so on the kernel from source code. So in the next nugget, what we're going to do is we're going to take the kernel source code and we're going to customize the modularness of the kernel. We're going to customize what things are modules, what things are included in the kernel, what things are not included in the kernel, and so on. So we're going to custom configure the kernel then, and then we're going to compile the kernel ourselves, and then we'll install it on the system, all of this from the kernel source code. Okay, now notice here I'm saying updating and not upgrading. Upgrading the kernel, what that means is upgrading the kernel from one version to a newer version. Alright, and that's what we're doing in this case for sure, installing the new kernel from an RPM file. But in the second case here, we could be upgrading the kernel to a new version, or we could just be changing the kernel. We could be customizing it, what modules are loaded in by default, what things are set as modules, what things are in the kernels all the time, that sort of thing. And here, it's not necessary that we're talking about a new kernel version, we're just talking about a new customized kernel. But this could also be a new kernel version. And like I said, we'll worry about this stuff in the next nugget. But in this nugget, we're just going to talk about installing the new kernel from an RPM file. Alright, let's walk through how to do the kernel upgrade with an RPM file, first here on the whiteboard, and then we'll move out to the Linux screen and we'll do it firsthand there, and you can follow it step by step. Alright, so the first thing that we have to do is get the newest kernel and put it in /temp. Okay, the kernel that we're going to get is going to be an RPM file, and it's going to look something like this. Okay, it's going to have the name kernel, followed by a version number, followed by an architecture .rpm, just like other software that we installed. It's got the name of the software, the version, the architecture .rpm at the end. Okay, so we're going to get that kernel version, we're going to put it in /temp, and then we're going to use the RPM command on that RPM file. And we're going to install the new kernel like this, RPM-I followed by the name of the RPM file. Now notice here, I'm doing an install and I'm not doing an upgrade. Okay, I'm not using the capital U option for RPM, I'm using the install option. Now the reason that I'm doing this is because I don't want to install a new kernel in case something is wrong with it, in case it's incompatible with something on my system like a hardware device or something like that. I want to upgrade it so that I have sort of two kernels side by side and I can choose which one to boot into. So if there's some problem with the new kernel and I use the upgrade option, well then I'd be stuck. I'd be like up a creek without a kernel or something, okay? Bad joke. Alright, but anyway, you see my point, is that if we upgrade the kernel and the new kernel's bad, then we don't have a kernel, a functioning kernel, and we can't boot into our system. Now we should always have that floppy boot disk around, that recovery disk, so that we can boot into rescue mode and do stuff from there. But it's going to be a lot nicer to have a fully functioning kernel, just like the old version of the kernel, have that version around so that we can boot into that and then debug exactly what's going wrong with our new version. Now when we do the RPM-I command, if everything goes according to plan, we're going to have the new version of the kernel, the new initial RAM disk, and so on. All those files that are associated with the new kernel are installed in the /boot directory. Okay, and everything's going to be there. Another thing that happens from the RPM with the -I command is a new stanza is going to be added to the grub.conf configuration file. Now grub.conf is what we use, that's the Grand Unified Bootloader. That's the thing that loads the kernel into memory when we start up our system. Okay, and there will be two stanzas in there, or at least one extra stanza. Whatever was in there before, an extra stanza is going to be in there now for the new kernel version. So before we might have had multiple stanzas to boot two different operating systems like Windows and Linux or something. And now we're going to have an extra stanza for another version of Linux. So grub.conf is going to have that extra stanza for the new version of Linux, but it's not going to boot that one by default. It'll still have set the default of the old kernel until you explicitly change it, that you're convinced that the new kernel is functioning properly. Then you can go in and change the default so that it boots off the new Linux kernel without making any choices. Okay, so that's how the general idea of how you upgrade the kernel by an RPM file. And now we'll go out to the Linux screen and do it firsthand, step by step. Alright, well now let's just go through firsthand those steps that we just talked about on the whiteboard. The first thing that you have to do is get the RPM file for the latest kernel. Alright, I've gone to redhat.com already in the Conqueror web browser here and found the page, and I'm just bringing you right to that page. Alright, so you can see here, generally this is under errata for the particular kernel that you're talking about. So here they said the updated 2.4 kernel resolves obscure bugs. Alright, and now you can see different versions of Red Hat Linux. So the way Red Hat works is that there's an underlying kernel, but that underlying kernel version could be running on multiple different versions of Red Hat. Okay, the reason they release new Red Hat versions is because something on the surface changed, maybe a graphical user interface or something they've added, and then they put out a new version of Red Hat. Okay, and so you have to pick the right version of Red Hat Linux that you have in addition to picking the right kernel version. So I'm running Red Hat Linux 8.0, so I'm going to click there. And now there's going to be a bunch of RPM files here as I scroll down for Red Hat Linux 8.0. And the first one here is source RPMs. Okay, so the kernel version is 2.4.20-20. The 0.8 there just means it's for Red Hat 8.0. That's a Red Hat thing to add that extra digit on the end. And you can see here it's a source RPM file. So if you're going to mess with the source code, do some development, if you're just extremely curious or you want to customize things and reconfigure and recompile it yourself, this is what you have to install on your system. Okay, we're going to not do that right now. Right now we're going to take the easy route and just take the binary RPM that's specific to our processor. All right. Now, for me, I've got an Athlon processor. If you're not sure what kind of processor you have, go out to the shell window and just look at proc/CPU info. Print that out to the screen, and it'll tell you all about your processor. You can see here I have an authentic AMD, and the model name is an AMD Athlon processor. Okay, so that's what I'm going to use, and you can pick whatever is specific for your processor, a 586 or 686 or whatever. Okay, and you can see here for an Athlon, there's a 2.4.20-20 kernel for an Athlon. There's another one down here with the same version number for an Athlon, but this one says SMP. Okay, SMP stands for symmetric multiprocessors. So if you have more than one processor inside of your computer, then you need to install the SMP version of the kernel so that you can utilize both processors, or however many processors you have. If you have 4 processors, whatever it is, so you can utilize the multiple processors inside of your computer. Okay, that's what that one you'd have to have. They recommend that if you're going to do the installation of an SMP kernel, that you also install the non-SMP version of the kernel. In case there's a problem there, you'll have this one as sort of a backup, so at least you can use one processor in the interim until you fix what's going on. Okay, so that's a word of warning from Red Hat. As we scroll down the screen here, you can see there's a section for Intel 386 processors, and this is kind of the default section. If you don't know what processor you have, or the processor that you have is not listed explicitly in this list as we go down, then this is the section for you. Okay, so at first, you know, we've got the plain old Intel 386 RPM. Then we've got a boot version, and this is to make an installation boot disk. Doc is for kernel documentation. If you're just upgrading the kernel, you don't necessarily need the documentation. Kernel source, again, that's source code for the 386 processor. Okay. Now as we go down, we go to Intel 586. Again, there's a regular version, and there's a version for symmetric multiprocessors. And then as we go down to 686, there's the regular version. There's the Big Mem version. So if you have more than 4 gigabytes of memory in your system, then you need to make sure that you have the Big Mem kernel. All right. If you don't have more than 4 gigabytes of memory, don't worry about it. Notice that 4 gigabytes of memory is only supported for the Intel 686 processor right now. And then there's an SMP version for the 686 processor, and that's the end. Now we're down to Red Hat Linux 9. Okay. So the one that I'm going to take here is going to be this Athlon RPM, just the basic one, and that's the one that we're going to install on my system. Okay, now let's look at, see this number here? Let's talk about what this number means. So if we go out to the Linux screen here, I've actually already downloaded that Athlon RPM. Let me just switch over to be the root user. And then let's do a listing in the /temp directory for everything that starts with cur. And you can see I've already downloaded 2.4.20-20.8 Athlon RPM. Okay, now what I can do is I can do what's called an MD5 checksum on that particular file. Okay, and what I do is I get this number back. Okay, this crazy number, 9EB393, exactly, okay? Now what I'm going to do is I'm going to come out to this screen, to the web page where I downloaded that from, and highlight this, and come back and just paste it in the window right underneath that with the middle mouse button. Okay, and now we can compare these two. And what we're comparing here is we're comparing what's called the MD5 checksum. It's an encoding of the file. It's sort of like a fingerprint for the file. Unlike fingerprints, 2 files could have the same MD5 checksum. Alright, but the number of fingerprints that are out there is like the square root of the number of atoms in the universe, or something ridiculously large like that. Okay, so the point is that if these two things match up, it is very, very highly likely that the 2 kernels, the RPM that I downloaded, has not been tampered with. It matches the checksum that's on it matches the checksum that's on the web page exactly. So it's very unlikely that somebody tampered with it. Okay, the beauty of the MD5 checksum is that if somebody did tamper with this RPM file in some malicious way, even if they tampered with it really, really slightly, this checksum would change dramatically. Like half the digits would be different if just like one little change was made to the RPM file. Okay, and so it would be obvious that these two things would be different if somebody tried to tamper with this in a malicious way. What you're really checking as well is making sure that the thing downloaded correctly and that there was some, there wasn't some corruption in the download process as well. Okay, so now that we're convinced that we've downloaded, sort of the clean version of this RPM file, now we're going to go along and actually do the installation of this RPM. Well, now let's actually do the installation using the RPM command. Let's just go to the temp directory where that RPM file lives, and what we're going to do is use the RPM command with the -i option. I'm also going to add on V and H there for verbose output, and the hash marks will print across the screen as it's progressing. Okay, but remember, we're doing an I for install, not a capital U for upgrade. That's important. So we're going to say kernel and give the kernel version number athlon.rpm. So this is the RPM file that we're going to install in our system for the new kernel version number. I'm going to hit enter, and now it's going to progress and do its thing. Okay, now when this is done, remember that the new kernel is not up and running, right? It's just installed in our system, and because we use the install option, all the old kernel stuff is still going to be around, okay? And we're just going to see new kernel stuff alongside of it in the /boot directory. We're going to see a new stanza in RHCE grub.conf, for instance, as well. Okay, so when this is finished and I actually get my prompt back, we'll go look at the grub.conf file and we'll go to the /boot directory and take a look around there. Okay, so let's go to the /boot directory first and do a listing. Alright, now in there you can see there's a config file for the old kernel version number, and there's a config file for the new kernel version number. There's an initial RAM disk for the old kernel version. There's an initial RAM disk for the new kernel, okay? And so on, module info, system maps, and the actual kernel itself for both versions of the kernel. Okay, so all the stuff there is now just duplicated. Okay, all the kernel stuff for the old kernel version, there's also a copy of it now for the new kernel version. And this is why we don't want to do an upgrade, because if something went wrong, all this old kernel version stuff would be deleted and it would just be replaced by the new kernel version number instead of being alongside of it. Okay, now let's look at the RHCE grub.conf file. Okay, now in this file, remember, I said there was going to be a stanza for each of the kernel versions, okay? And here are the two stanzas. This stanza is for the new kernel version, okay? And this stanza is for the old kernel version. All right, remember though that stanzas, the stanzas here get labeled. The first one is number 0 and the second one is numbered 1. Okay, and up here you can see the default is number 1, which means by default the first stanza is going to be booted if you don't make a choice, and the first stanza is really the second one because we start numbering at 0. Okay, so the one that will get booted by default is the old kernel, not the new kernel. But when we go and shut down the system and reboot it and we get to that grub screen, we're actually going to have a choice of which one of these we boot up, because there's going to be two options in there. Okay, and that's what we're going to do right now. We're actually going to go and shut down the system, and then when we shut down the system, we'll come back and I'll show you the boot screen, the grub screen, where we actually have our choice, and then we'll come back and boot up the new kernel and see how it's working. Alright, so here we are at the grub screen. I've shut down my system, I restarted it, and now the grub screen is showing two different versions of Linux that I can choose from. Okay, if I just hit enter here, I'm going to boot into the old version of Linux, or if I just wait the required like 8 seconds here, then that will be the one that boots by default. If I want to boot the other one, all I have to do is hit the up arrow and highlight that one, and then hit enter, and then I will boot into the brand new kernel that we just installed on the system. Alright, so I'm going to hit enter here, and then I'll see you back inside at the Linux screen with our new kernel in place. Alright, so now here we are logged into our new system. Now this really isn't a new system, right? All we've done is upgrade the underlying kernel. All of the directories and the files that we created, the user accounts that we created, everything like that is still in place. We've just upgraded the underlying kernel. So let's look at the uname command and see that we're actually running the new kernel version. And you can see here that we are running 2.4.20-20. All right, well, congratulations, you've updated the kernel. And that's nothing to, sneeze about, right? That's actually an important task, especially in a production environment, to keep your kernel up to date so that all the various security flaws that are known about the kernel are fixed on your system. You don't want to have, the hackers or the crackers out there that are trying to crack into your system be one step ahead of you. Okay, you always want to have all the latest patches and so on updated on your system. All right, so now we've got this kernel version updated. Now the question is, how do we know that this kernel is actually functioning correctly? Well, in a home system, you'd probably test out the various hardware devices and things like that to make sure everything works on your system. In a production environment, though, you want to be really careful about upgrading kernels on a production machine, like a web server or something that people are logged into, that the crux of your business depends on. When I worked at that internet company in Seattle, whenever we were going to do an upgrade to the kernel, we would always upgrade a machine in a testing environment, and then we would sort of pound that machine with load to make sure that it could handle the various load. And what you're really testing is not that the kernel patches that you've applied are correct. You're testing sort of the compatibility between the software that you've written and the new kernel version to make sure that you weren't relying on some aspect of the kernel that was found to be an error. Okay? And most of the time, for small patches like 2.4.18 to 2.4.20, there's really no problems that can creep up there. But like if you're going from a 2.4 kernel to a 2.6 kernel, for instance, that's a bigger change, and then you would do more extensive testing. But even for us, even if we were doing a small upgrade, what we would do is we do the test in the laboratory setting, pound it with load, make sure everything works, and then in the production setting what we would do is we would go ahead and say we had 20 web servers responsible for serving up our search engine. Well, then what we would do is we would upgrade the kernel on one of those production web servers, and if everything worked there for a while, we tested it over the course of like some heavy load days, then we would go ahead and upgrade the kernel on the rest once we were convinced that the one machine in the production environment responded well to the kernel upgrade. Okay, so that's what we would do in the production environment. Let's just look at the /boot directory again and look around in there. And remember that all of these 2.4.20-20 files are the ones that were used now when we booted up our system. We used this initial RAM disk to boot our system, and this is the kernel that we're actually running now on our system. Okay, so you might be tempted to go and back and delete all the things that say 2.4.18-14. And why not, right? If you are convinced that the 2.4.20 kernel is working correctly, then, save some disk space and go back and delete the old stuff. I would actually caution against that, though. Here's why. I think that it's good to have two kernel versions in place in the /boot directory. The /boot partition is easily big enough to hold two complete kernels. Okay, it's big enough to hold two RAM disk images and two config files, two system maps, and two actual kernels in it. Okay, and so I think it's good to have one old version that works, leave that around in the /boot directory. And the reason why I think that's a good practice is because if some problem eventually creeps up with the new kernel, you can always just shut the system down, reboot it, and when you get to that grub screen, you can select the old kernel version and boot into that, and that one works, and then you can go ahead about your business with a fully functioning kernel, just not the latest, the latest, greatest kernel, the most updated kernel. Alright, so that's why I think you should keep that old one around. Now, if you do multiple upgrades, say we went from 2.4.18 to 2.4.19, and now we're going to 2.4.20. Well, it's not necessary to keep all the old versions around, and the /boot directory isn't big enough to keep, 4 or 5 or 6 kernels in it. So you have to draw a line there and say which ones do you want to keep around. And like I said, I think it's good to keep like the newest one and the one just before it that was functioning, and then any before that you can go ahead and just delete all the various files that have to do with the oldest kernel. Alright, well that wraps up our first nugget on the Linux kernel. What we focused on specifically in this nugget was upgrading the Linux kernel from an RPM file. Okay, and we wanted to do this so that we're up to date with all the new security fixes and so on that are present in the new kernel. So remember, when you're picking the RPM file to download, choose the most specific one for your architecture. I have an Athlon processor, so I chose the Athlon RPM. If you have an Intel 586 processor, you choose the i586 RPM. Remember to choose the RPM file with SMP in the name if you've got a symmetric multiprocessor unit. Remember to choose the one with Big Mem in the name if you've got an Intel 686 machine with more than 4 gigabytes of memory. It would be a crime to have a multiprocessor unit or a unit with more than 4 gigabytes of memory and you don't load the right kernel to utilize that stuff. You paid for that extra processor, you paid for all that memory, make sure you load the right kernel in so you can utilize that hardware. And remember, to install the new kernel, don't upgrade the old one. You want to install the new one so that you've got two side by side, so that if the new one isn't working for some reason, you can always go back and boot into the old one. Also, don't forget to make a boot disk for the new kernel once you've installed it and you think it's functioning correctly and everything. Make sure you make that boot disk for the new kernel using the make boot disk command that we learned back in the nugget on the Linux rescue process, just so that your boot disk is up to date with your new kernel. And remember that once you're convinced the new kernel is working, you want to go into the grub.conf configuration file and change the default variable so that it boots off of that new kernel. Well, I hope you found this nugget informative, and thanks for watching, and stay tuned for the Linux Kernel Part 2, where we're going to learn how to customize and compile the kernel ourselves.